also say to that point, you know, the wind was probably the only thing of Mars we were going to actually hear, so you didn't want to negate it completely anyway. Normally, when you're doing field recording, you want to hear everything but the wind. In this case, I mean, there's nothing else to hear, right? So besides that, you know, there wasn't really any possibility to put a pop filter or not a pop filter, like a windsock or something on it like you normally would, because all the materials that we sent had to be very rigid, and you know, you can't like, there's a lot of weird things that I learned about that I didn't even know existed prior to getting this gig. And one of those things is that when you fly materials into deep space or into a vacuum, any vacuum, but if you fly them through deep space for, you know, 6 months, they start to kind of evaporate. It's a process they call outgassing. And what happens is that small air particles that are microscopically captured inside different materials, like certain rubbers or plastics or things like that, the vacuum will draw those out. And over a period of 6 months, you basically, these materials get leached out of these various things. So that's why, for example, every circuit board that gets printed, that gets put onto a spacecraft, has to be like coated with this epoxy, like a clear epoxy, to basically make sure everything's like, you know, glued in there. Obviously, we don't want to spray our microphone with an epoxy covering, because then you're not going to hear anything. But so we couldn't protect anything like that. And so we basically had to be very cautious to not include any materials that could possibly cause any sort of, what they call it outgassing, this evaporation, which includes a lot of, materials like foams and things like that. So if we were going to make a windscreen, it would have had to been a metallic one. Now,